Okay, so round 2 of sine rule, cosine rule stuff. So I have triangle RST. And I'm going to change those names to ABC. So this is CBA. So you don't have to do that if you don't want to, but I'm gonna do that. So RST becomes ABC, just so you can get used to where you put things, and you'll eventually figure out whether you need to do that shortcut or not. Okay, label the pictures. C is 9. S, which is B, is 14. And A is 6. So clearly I have no angles here, so I have to use cosine rule. And so the cosine rule, you can start out with any angle that you want to find. So you might say, well, okay, I want to do the way the rule is first written: a squared equals b squared plus c squared minus 2bc cosine a. Remember that a, b, and c are multiplied together here, and the a matches up with the a. You say, well, I'm trying to find the angle, so I really need to have cosine a be by itself. So it is solved by itself for you on your formula sheet, or you can just plug everything in and then solve at the end. It doesn't matter. So to solve this, a squared, I'm going to move the b squared over by subtracting. I'm going to move the c squared over by subtracting, and then I'm going to divide by negative 2bc. So that equals cosine of a. So sometimes when people write it, they just take a -1 out of everything. So it would say b squared plus c squared minus a squared all over 2bc. It doesn't matter. I'll go ahead and write like that. That's probably how you see it on your formula sheet. So you take a -1 out of this, take a -1 out of this, take out 2 -1s, they're just canceled out. You could also have just plugged it in right there and solved. This is on your formula sheet, and this is on your formula sheet. You just got to be able to manipulate it. All right, so now it's easy. Just plug in your numbers, but don't screw up your calculator. It doesn't make mistakes, but you surely can. So make sure that you don't let your humanness get in the way of this good math that could happen. So B is 14, A is 6. So just remember to not do sillies on your calculator. Whole fraction in parentheses. Some of you, by taking little steps along the way, you mess up how you enter things. Use your calculator like it was designed, and that's to be a high-level calculator. And your brain knows the order of operations. I need to do this whole thing. Don't push one number, hit enter. Push one number, hit enter. Push one number. You're going to mess up your calculation. Okay, so I got 1.43. And what I know is that there's no way I can do the cosine of 1.43. I'll try it. I'll go second cosine of my answer, and you get a domain error. So something was entered wrong. So let's go back and check it. So it should be b squared plus c squared minus a squared over 2bc. And if you notice, I put 2ba because that's what it looks like on my paper. Now let's see if that fixes it. Some of you hopefully caught that along the way. This is good. Now it's less than 1, so I know at least I can get a value. Second cosine of my answer. So 16.999, whatever, 17 So A equals 17 degrees. So put it on your picture. That's also known as angle R, because you know I changed them. Now you do law of sines from here. So that's angle A on mine. So 6 over the sine of 17 equals 14 over the sine of B equals 9 over the sine of C, which I won't need to find that last one because I'll be able to subtract from 180. So let's just look at these. Calculator again. Remember, you're finding angles, so you're going to do second. So 14 times sine of 17 divided by 6. Now do second sine of that 43 point. So B equals 43.0. And herein lies the trouble. Well, troubles. So let's do the other one just to see if it makes sense. So I'm going to look at this, and so I'm going to take 9 times the sine of 17 divided by 6 and do second sine of my answer, and that is 26. And so you might go like this. Well, wait a minute. These do not add up to 180. I did them on my. I could have subtracted them and got 180. Those did not add up to 180. Well, this, my friends, right here is one of the troubles of this sine rule. And so it's worth checking all three to make sure your angles don't add up. There is something called the ambiguous case. Okay, and I'm going to have you actually look at something on that a little bit later on, but I'll explain it here just really quick. Okay, I got a picture. Let's see if this helps a little bit. So we knew these sides here. We actually knew the third side as well. So when you went to use law of sines, you had this angle on this side, and then this angle on this side. Well, if this length A and this length A, you could actually take this piece and move it here, and it could flip back, and I didn't get a very good sketch, so I didn't make it to scale, but you basically turn it into that triangle. So if you pick the wrong side, it's vague in that you could get two answers. Okay, so how do you figure that out? Well, make sure you check all three. That'd be the number one way to make sure you check all three and say, well, we did law of cosines for angle A. Let's do law of cosines for angle B. So following your same pattern, cosine of B equals A squared plus C squared minus B squared all over 2AC. And I'm just taking and reversing the pattern around. So plug in your numbers. So parentheses 6 squared plus 9 squared minus 14 squared all over 2 times 6 times 9. 137. Okay, and that is our angle B. What do you notice here? Those add up to 180. And that is where the ambiguous case happens. But if you use law of cosines, it won't ever happen. So again, if you're going to finish the problem out with law of sines, I'd say go ahead and check it out. You want to look up a video right now, ambiguous case. And you only need to worry about it with law of sines. Okay, so that's your explanations. Go back and finish the rest of the sine rule, cosine rule.